Sir, good afternoon po. Kami po yung Group 4 and we discuss about different flows of in pipes. Next. So, shearing stress and pipe flow. Shearing stress. Shear stress force tending to cause deformation of a material by slippage along a plane or planes parallel to the imposed stress. The resultant shear of is of great importance in nature, being intimately related to the downslope movement of earth materials and to earthquakes. So meron ditong picture ng river, which is one of the example na nagbibigay ng shear stress yung flow ng tubig sa river. Shear stress kasi ay yung stress or sabihin na nating friction ng tubig sa pagitan ng plates or dun sa isang bagay na dinadaluhan niya. Next. So, meron ditong sample problem. The velocity distribution for laminar flow between parallel plates is given by the equation of U over U max equals 1 minus 2y over h squared. Yung value ng U max natin is 0.30 meter per second. Tapos yung water naman is at 15 degrees Celsius. Hinahanap dito yung shear stress sa upper plate and give its direction. De Los Santos po. U po. Opo. Yung hindi opo, pero hindi ko po siya sa libro nakuha. Na-search ko lang po siya. Pero ang ano po, ang pagka sa actually sir sa ano siya, example siya sa isang YouTube video which is yung pag explain ng nag-explain doon or professor, U. Opo sir. Yes sir. Yes sir, velocity po yung okay, next. So gagamit tayo ng Newton's law of viscosity which is yung anong basa anong basa dito? T equals mu over du over dy. Then, i-apply natin yung equation na binigay kanina, du over dy equals 1 minus 2y over h squared. Then, derive. Pag dinerive siya, makukuha natin yung negative 2y over h and 2 over h. Then, next is yung t equals to negative 8 mu u max y over h2 ay h squared. So, ilalagay na natin yung mga value kanina. So, negative 8 times 1.3 ay 1.3 times 10 raised to negative 3 kilogram. Tama ba? Kilogram meter per seconds times 0.3 meter per seconds, then 0.25 times 10 to negative 3 meters. Yung 0.25 times 10, nakuha natin siya dun sa height na 0.5 mm. Divide lang kasi naglagay tayo sa gitna ng coordinator niya. Bakit kalahati lang ng 0.5 yung kinuha natin? Kasi yung kalahati lang yung kalahati lang ng pipe yung kailangan nating mahanap yung shear stress over 0.5 times 10 to negative 3 meters squared. So compute which is negative 3.12 Newton meter squared. So dito may illustration tayo dito. Yung illustration dito is nagpapakita ng direction ng stress sa wall saka yung direction ng fluid. Since nakuha tayo ng negative 3.12 na value, so negative siya, papunta siya sa left Then yung stress naman sa wall is papunta sa right. And next. Next reporter, please.
So, next po natin is yung sa Reynolds number. So, noong 1883 po, isang Irish scientist, si Osborne Reynolds, conducted an experiment po. And ganito yung setup ng experiment niya. And yung experiment po na to is nag-lead sa kanya para ma-discover yung unitless o yung dimensionless number na nagpe-predict ng fluid flow. And then, ito nga yung Reynolds number, obviously, it was named after him. And then yung Reynolds number yung ginagamit para ma-differentiate yung type ng flow na kunwari meron sa isang pipe. Yung sinasabi ng type na flow dito is either kung laminar siya or turbulent flow. So, Reynolds number is defined as the ratio of fluid's inertial force to its viscous force. And then inertial force naman is yung force due to the momentum of the mass of flowing fluid, while viscous force naman nagdidil siya sa friction ng flowing fluid. So yung kanina nga nakita natin is yung setup ni Mr. Reynolds. So yung experiment niya is nagko-consist ng dye water tank, and then yung glass tube tsaka valve. Tapos ito, water po to. Then, during the experiment, itong dye water na to is nirelease siya dito sa glass tube para ma-visualize ni Mr. Reynolds kung ano nga ba yung movement ng flow. Then, yun nga, inopen niya to ng kaunti and as a result, nakita niya na yung flow ng fluid particles is ganito, which is in parallel. So, tinatawag niya to na laminar flow na kung saan fluid particles move along well-defined paths or streamline and it's all straight yun nga and parallel. And the reason behind this daw is because of its low velocity. Then, nung inopen niya po ito ng kaunti pa, edi yung velocity is little more than before, kaya yung dye water is nagpo-form na siya into waveform. So, kapag nasa waveform na daw yung fluid particle, ito na daw yung transition ng laminar into turbulent flow. And nung binuksan niya na to totally yung valve, ang naging movement na nung flow is zigzag way na siya or nagtatamaan na siya sa isa't isa. And ito na nga daw yung turbulent flow and dahil nga ito sa higher velocity and nung sa experiment niya, yung dye water na to is nag-totally diffuse na siya into the water. And yung mga factors daw kung bakit nagkakaroon ng change between laminar into turbulent flow is yung increase ng velocity, increase din sa diameter of pipe, and yung resistance to flow niya is nagdi-decrease. So, next is, ito na yung formula for the Reynolds number. So, R is yung Reynolds number nga, which is unitless. And then, for fluid density in kilogram per cubic meter, meter per second for its velocity, meter para sa diameter ng pipe, and viscosity of fluid sa Pascal per second or meter square per second kapag kinematic yung nasa problem. At, di ba, pag kinompute na natin siya, tapos ang naging result daw natin is less than 2,300, magiging, ang type ng flow is laminar flow. Kapag greater than 4,000 naman, turbulent flow to. And pag between naman ng dalawang number, ito na yung transient flow na kung saan yung fluid flow is transitioning between laminar into turbulent flow. For the sample problem, a Newtonian fluid with a density of 910 kg per cubic meter flows through a 25 mm diameter pipe with a velocity of 2.6 meter per second and viscosity of 0.3 Newton per second meter squared, or Newton second per meter squared. Determine Reynolds number. So, dahil nga alam na natin yung formula for the Reynolds number and given naman na yung density which is equal to 910 kg per cubic meter and then 2.6 meter per second para sa velocity niya. And yung diameter ng pipe natin is 25 mm. I-multiply natin siya sa 10 raised to negative 3 kasi nga meter yung need natin. And then 0.3 para sa viscosity niya, 0.3 38 Newton second per square meter. And i-substitute lang natin siya dito sa mismong formula, and then ang sagot natin is magiging 156, and less lang siya sa 2,300. So, ang type ng flow na meron dito sa pipe is laminar flow po.
Turbulent flow. In fluid dynamics, turbulent flow is characterized by irregular movement of particles. No one can say chaotic of the fluid. Turbulent flow tends to occur at the higher velocities, low viscosity, and the higher characteristic linear dimension. Ito po yung para ma-determine kung turbulent. Unpredictable, occurs on many scales, diffusive, high R in number, dissipative. Next. Turbulent wave. It's a disturbance or defect created in a steady flow. It's a stronger due to convection acceleration. Yung turbulent flow po yung ano ba yun? Yung irregular movement of ano po? Irregular movement of water po. Magkaiba yung laminar flow po isang direction lang po. Yung turbulent sabog-sabog. Next. Uy. Tapos na yun. Why it is important to know it carries great energy with it negative wave disturbance for the backflow. Gaya ng sabi ni Jess kanina, yung turbulent flow, ano ba yun? Okay. Yung nagkakos ng turbulent flow is sharp corner, yung ito po yung bias type of turbulent waves. Ayun po, parang wave. Iba-iba yung direction. Next na nga. Ako po, sir. Pangilinan po. Ayun po. Opo, sir. Ayun po, yung pag-ano ng po, yung wind. Yung parang na iba po yung direction. No? Opo. Yung more. Opo, sir. Wala po, sir. Tapos na po, sir. Opo. Wala po. Opo, sir. Sinabi ni Jasmine kanina yun, sir. Hindi po. Jazz, kanina ba yung Jazz?
Critical velocity. Critical velocity is defined as the speed and direction at which the fluid flow through a conduit changes from smooth or laminar to turbulent. So, ang critical velocity, ito yung kung gaano kabilis sa isang direction po yung takbo ng fluid. It's either sa smooth or laminar flow. Yung critical velocity nakukuha sa formula of V sub c, which is the critical velocity is equal to the Reynolds number times the coefficient of viscosity all over the density of the fluid and the radius. Next. Yung velocity distribution, not all the fluid particle within the pipes travel at the same velocity. Syempre po, 'di ba, ang flow po maraming factors na nakaka-apekto like yung surface po ng pipe, the smoothness and the roughness po ng pipe. Kaya po paiba-iba rin po yung takbo ng yung distribution of velocity. The velocity distribution across any given section at the pipe depends whether the fluid flow is laminar or in turbulent. Sa next page, dito po makikita mo po yung velocity distribution ng laminar flow. Ang velocity distribution niya po ay sa laminar flow nag-create po siya ng parabolic curve compare po sa turbulent flow na medyo flat po.
So, friction factor. Today, since na-mention na nila yung iba kanina, like laminar and turbulent, so today we will discuss about the concept of friction factor. So, what is friction factor? Next. So, friction factor is representing the loss of pressure of a fluid in a pipe due to interactions in between the fluid and the pipe. And since the major loss or head loss due to friction is given by HF is equal to 4LFB squared all over 2GD, and this is called the Darcy-Weisbach formula, and the F called as a friction factor, and for that we will show you a graph to explain. Next. So in this graph, as we can see on the y-axis we have the friction factor, and on y-axis we have the Reynolds number. From this graph, we can see that if the Reynolds number value is less, the friction factor is more or increase. And Reynolds number value would be less if there is a laminar flow. Then if the Reynolds number is increased, then that is the case of friction factor. In that case, the friction factor is reduced. As we can see here, the friction factor is reduced because the Reynolds number is increases, and that is case of turbulent flow. And friction factor direct on which the head loss due to friction difference that is directly proportional to HF. So if friction factor is more or greater, HF value will go on increasing. Similarly, if friction is less, the HF value will decrease also. So in short, if the Reynolds number is less, that is increase of laminar flow, and the friction factor will have a greater effect, and hence the head loss due to friction will increase. So next, here are the formula to get a friction factor for both laminar and turbulent flow. For example, for a circular pipe, if the RE or Reynolds number is less than 2000, then it's called the laminar flow. And if it's laminar flow, the friction factor formula will be F is equal to 16, which is constant all over RE or Reynolds number. While if it's turbulent flow, if the RE or Reynolds number is greater than 4000, the formula of friction factor will be F is equal to 0.09 RE, Reynolds number, raised to 1/4. Next presenter, please.
Darcy-Weisbach formula. Next. What is Darcy-Weisbach formula? It is a flow of fluid through a pipe. The flow of liquid through a through a pipe is resisted by viscous shear stresses within the liquid and the turbulence that occurs along the internal wall of the pipe, created by the roughness of the pipe material. Weisbach first proposed the equation we now know as Darcy-Weisbach formula or Darcy-Weisbach equation. HF equals to F L all over D X V all over 2G where HF equals he- head loss M, F friction is equals to friction factor. L, L is equal length of pipe work and D is equal to inner diameter of pipe work. V is equal to velocity of liquid and G is equals to acceleration due to gravity. Next. Yung H po yung malaki, yung F po yung maliit. V squared po. Okay. Apo. Head loss of Darcy-Weisbach equation. Delta H is equals to Eb sub D and L all over D and V squared all over 2G. Darcy-Weisbach equation. H sub F is equals to F L V squared all over 2GD. That's
Ala, ako na.
Lakatan.
Sir, next na sir. Ako na po. Tara kayo na sir. Other losses of bed and energy principles. Next po. Head loss. Passing a certain volume of liquid through a pipe requires certain amount of energy. It's primarily linked to the friction, which in turn depends on the properties of fluid as well as other parameters like velocity, diameter of pipe, and internal roughness of pipe, and etc. Kasi ito yung formula po. Say sub 1 plus P sub 1 over PG plus V sub 1 squared over 2G is equal to say sub 2 plus P sub 2 over PG plus V sub 2 squared over 2G plus HL po equals HL nga po, yung head loss. May dalawang classification ng head loss po. Yun. Major energy losses. Yun po, due to friction and are calculated by Darcy's Weisbach formula, Chassis formula, Hazen-Williams formula, and modified Hazen-Williams formula. Yun nga po, binanggit na po kanina ni AJ, sabihin na po yung Darcy's Weisbach formula po. Next po. Alin po? Anong head po, sir? Yung velocity, diameter, ganun po ba yun? Velocity, diameter of pipe, and internal roughness of pipe po. Opo. Ay, sige po, sige po. Paulit nga po, sir. Sige po. Hindi ko po alam, sir. Hindi ko po na ano eh. Velocity po. Sige, sir. Diameters po. Pressure po. Yung B po, yung velocity po, tas ay ano po yung side po. Opo, opo. Yung B po, ed yun. Yung B po, ed. Tapos yung Z po, yun po yung ang tag dito, elevation po. Yung head po. Pressure head po. Velocity head po, yung ano, elevation po yun. Opo, opo. Minor losses po, due to sudden enlargement, due to sudden contraction, due to entry of pipe, due to exit of pipe, due to elbows and pipe bend, due to valves and other fittings, due to obstruction in pipe. Next po. Yan lang po yung nakita kong answer na picture. Ano, sir? Alin po? Sa mga pipings po. Yung pressure po ng ano, sa mga bends po ng pipes. Opo. 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 Wala po. Magdire-diretso lang po. Meron po. Opo, sir. How to minimize head losses in the pipe. Correct sizing of pipe, optimizing the network length, inner surface roughness of the pipe, streamline design. Yun lang po.